All right, so when we talk about real numbers, today's more about vocabulary. I know you have done these before. Brett, you're with us, right? All right, thank you. So the very smallest category of real numbers is called our natural numbers. Natural numbers are our counting numbers. So they're what we count with, if I can spell correctly. All right, so that's the very smallest group we have. So you start with 1, 2, 3, 4, and so on. Okay, so I'm going to put a little box around our smallest group. And again, those are like 1, 2, 3, 4, 5. Now our next biggest group includes all of those. So I'm going to kind of extend this box a little bit. But it adds one more number to it. So not only does it include our counting numbers, but now it also includes 0. So 0, 1, 2, 3, and so on. These are called whole numbers. You should have last year. So that is our counting numbers and 0. All right. The next biggest category. So I'm going to take this. It includes all of those. So I'm going to extend my box again. It includes all of those. These are called integers. Integers are your counting numbers and their opposites, plus 0. So when I say they're opposites, let me finish writing, and 0. Yep, they're negatives. So we can have -3, -2, -1. We can have 0. We can have 1, 2, 3, and so on. All of those are integers. Our next category, which includes all of these, are called rational. Rational numbers are any number that can be written as a fraction. All right, so we can have 2/3 as a rational number. We can have 16 over 4. That's a fraction, but what number is that actually? 4, exactly. I can have -20 over 2, which is actually -10, but because I can write it as a fraction, it's a rational number. Okay? So if I have something that's a natural number, it's everything else as well. All right? Now we have one category remaining that doesn't fall in any of those. So it's not inside our boxes at all. Irrational, very good. Irrational numbers. All right, now the definition I'm going to give you for irrational, this is how I want you to remember it. And then we're going to talk about what it means. Irrational numbers are non-repeating, non-terminating decimals. Okay, so when I say non-repeating, if I have a decimal that's 0.33333, that's repeating because what fraction is that? 0.3 repeating is what fraction? 1/3. Does that sound familiar? Okay. So if it's repeating, it can be written as a fraction. Non-terminating means it's a decimal that's going to go on forever. One of the most famous irrational numbers is pi. Pi is an irrational number. Okay? Another irrational number might be the square root of 2. So go ahead and grab your calculator. I want you to type in the square root of 2. So it looks like it stops, doesn't it? Even though it goes all the way to the edge, it does keep going. It's just it gets smaller and smaller and smaller, so your calculator stops writing it out. Yeah, that's fine, or you could just write it out to there. But I wanted to show you that this is an irrational number. The numbers aren't repeating, and the decimal goes all the way to the side of your screen. Okay? These are the different categories we're going to classify in. So your first problems today, it is going to ask you to name the subset. So here we go with example number 1. Name the subset. All right, and this is problems 28 through 36. So when you refer back to it, so let's say I give you the number -7. Where does that fall, Justin? It is rational. What else is it? Oh, yes, I can. Yep. Yeah. All right, so it's rational. What else is it? Anybody else? It's what? Integer. Very good. This is also an integer. So we need both words here. An integer, remember, is your positive and negative counting numbers, and rational can be written as a fraction. I can move it down now, Justin. Are you good? A little bit? Okay, I'll go to there. How about this one? What if I just said 1/2? What is that one? So look at our different categories. We have 5 options. Is it a counting number? It would be rational because it's a fraction, right? It can be written as a fraction. So this is rational. What if I just said 7? What is 7? All of them. It is natural, whole, integer, and move that up just a little bit, rational. Okay? So your first few problems, that's all you have to do. Any questions? All right. Next section then. In the next section, we're going to be comparing numbers. When you compare numbers, we have to change them all into the same form. So I'm going to ask you to change all of them into a decimal. All right? Which you have calculators in front of you that can change them quickly to a decimal. And you write the decimal down. Okay? Let me know when you're ready, Justin. Good job. All right. So when comparing always change to a decimal. All right, so here is example number 2. This is going to cover your problems from 38 to 44. State which is greater. Now your book suggests, oops, I lost my A in there. Your book suggests you use an inequality symbol, which is fine with me if that's what we want to do. So if they give you two numbers, let's say they give you, how about 13 over 5 and square root 5. To decide which one's bigger, we're going to have to change them into decimals. So the first thing we're going to do is we are going to type in 13 divided by 5. And I get 2.6. I'm going to write that decimal down. That's going to be my work so I can see what's going on. Then I've got to type in the square root of 5. What did you say it was? 2.2? 2.236. All right. So now, which one of those two is bigger? 13 over 5. So if we're using an inequality sign, remember your alligator always eats the bigger one, I personally prefer if you just circle it. So you can do it either way. Okay? But the work I'm looking for are your decimals. Okay? Questions on those? Do we need another example of that? You guys be honest with me. If we do, I'm more than happy to do it. No? Okay. Let's go to example number 3 then. Example number 3. This is the 46 through 50. So this will be our last example. And the directions say order numbers. From least to greatest. All right. So let's say I give you a list of numbers. Let's start with 4 over 5. Maybe I give you 0.75. Square root 2. And 3 over 7. All right, now in order to put these in order, we got to change them all into what? Decimals, absolutely. So right underneath all of them, I'm going to change each one into a decimal. So 4 over 5, 0.8. This one's already a decimal, so I'm just going to write that down. The next one I get 1.414. And the last one, 3 divided by 7 in my calculator, gives me 0.428. All right. So now the least, the smallest one is which one of the numbers up there? 0.428 is the smallest, but here's what I got to have. When you write them down in order, after you put the decimal down, I need you to put the original form. So we have 3 over 7 is the smallest. All right, that's that one. Now what? What's the next smallest? 0.75. Good. All right, we have that one. 4 over 5. Excellent. Square root of 2. Okay? So this is the form I'm grading, but I need to have this work so I can see you understood which one went where. Okay? Do we have a question on that at all? No? All right. What about if they were negative? What's special about negatives? Ben, what do you think? Okay. Good. The one closer to 0 is greatest. Very, very good. Okay. So you do have one that's got some negatives in it. All right, so your homework is on page 20, 28 to 52 even. I have posted in Google Classroom as well. All right, so I took a picture of it, posted in Google Classroom if you don't want to take your book home later. I will be uploading these notes into Google Classroom, and I will put the video in Google Classroom. So all of that will be there for you. So you're going to, on a separate sheet of paper, do all of the work for these few problems. Okay? It's not that many. You guys totally got this. Cool beans. And I